Shankar Rao, sir.
Madam, is audible? My voice is audible.
Yes, sir. Audible, sir. Sir, sorry for the interruption and sorry for the late also, sir. Now I'm inviting, it's my honor. Now I'm inviting Dr. Shankar Rao Mutyala, sir, who is the Director and CTO for Nanosol Energy Private Limited, Hyderabad, Telangana. Dr. Shankar Rao obtained MSc degree in chemistry from Andhra University, Visakhapatnam, India in 2009. After that, he qualified in National Eligibility Test and Graduate Aptitude Test in Engineering, followed by PhD from CSIR, Central Electrochemical Research Institute, Karaikudi. Later, he worked as a National Postdoctoral Fellow in Indian Association for the Cultivation of Science, Kolkata, West Bengal. Currently, he is the co-founder and director of Nanosol Energy Private Limited Company, Hyderabad. He has sound knowledge in synthesis and assessment of various catalyst materials like CNTs, graphene, and its related materials for low temperature fuel cells, membrane electrode assembly, green hydrogen generation through PM, AM, and alkaline electrolysis, and other energy applications. Improving the efficiency of PEM fuel cell by designing of efficient catalyst, electrode fabrication, promotion of innovative strategies to make reliable systems for applications in a portable and transport sectors. Sir has more than 32 research articles in international journals and 4 book chapters. He is showcased his research finding in various platforms right from universities, research institutes, industry conclaves, expos, workshops, training programs, etc. in India and in abroad. Uh, and it's my request to take over the session. Shankar Rao sir to take over the session.
Hi, sir. Hi, madam. Thank you for your nice introduction. And I hope my audio is audible. My voice
Audible
is audible.
sir. Audible
Okay,
sir.
madam. If anything is there, any problem is there, please let us know, madam. Then I'm
Sure sir.
start my presentation.
Sure sir.
And this is my brief introduction. And I hope I am very happy to deliver this lecture in this institute. So this is my brief introduction, as madam told. And I did my PhD from Central Electrochemical Research Institute. This is the only institute in Asia is exclusively work on this electro-based techniques like electrolysis, hydrogen generation, or corrosion studies, or batteries and fuel cells, as well as this various areas related to the electrochemistry. So this one, so electrochemical energy sources is mainly classified into four types. One is for the batteries, fuel cells, as well as the electrolyzer and supercapacitor. Whereas these batteries still further classified into lead acid batteries, lithium ion batteries, and flow batteries and zinc ion batteries. So these are the primary batteries are there, secondary batteries are there. So based on the applications, so batteries are classified. And now I'm going to discuss about in my coming slide. I am brief about what is hydrogen and why is the green hydrogen and what are the techniques. Also, pure uh, pure technical process and what is the engineering behind that. So, and what are the opportunities are there? What is the global scenario of the hydrogen economy as of now? And what is the India's contribution so far? And what is India is looking for the next 3-4 decades to achieve the net zero targets? And followed by, so what is our activities is doing in India? So these are our four techniques. One is the fuel cells, low temperature fuel cell, as well as high temperature fuel cells, and electrolyzer. So electrolyzer is nothing but the generation of hydrogen from the gas and the liquid, alkaline electrolysis, PEM electrolysis, and solid electrolysis. And these are the supercapacitors. So across the globe, there people are working on this. Initially, they work on this basic R&D, process R&D, and product development and like that. So in recently, they classified into 9 levels. That is called TRL level, technology readiness level. The technology readiness level means if that the idea of the your product, something you want to bring something who want to bring into the market, first you should have some idea. Then you have to work into the small prototype. That is comes under the TRL level up to 3 or 4, or the study of the particular new product, or and publishing some research article. These are the comes under the up to TRL level 3. That is called ideation and conceptualization, and designing of the prototype, and fabrication and assembly of the prototype. So the upper three parts is majorly available, possible in the academic institutions, or whether it is IITs or CSR labs, or deemed universities, or state universities, or central universities, or like engineering colleges. So wherever it may be, these are the three phases mainly possible. So the academic institutions is meant for to work on the deep R&D project, and to study in depth of that particular prototype, and they will fabricate into the prototype. So these are the, so based on their research findings, they will publish on the papers, and they will file the patent, and they will go for the transfer the technology. First one they will do, they will write a research article, and if it is a prototype, they will work on this patent, and they will hold the patent, followed by they will develop the prototype. Still it is a working model, and it is useful for that uh, society. They will transfer the technology to the particular industry. So these are the three levels. Up to this one, we can call it as a TRL level 4. Once the academic institutions or particular organization is transferring the technology to the industry, once the industry take the technology, so they will bring into the market. So that is what we are, it is there in our hand of any product that is crossed TRL level 3. So before TRL level 3, yeah, so crossed, it is our hand, it is called TRL level 9. Sorry for that. So the product, what is there in our hand, that is TRL level 9. So before coming to this, our hand for the particular product, they will do different prototypes. I think already you come across hydrogen buses, or battery buses, or uh, Vande Bharat train. So now the trial run is going on this term, or this for 1 month it is a trial runs are going on the different trains, or they're checking the track. See, all these things is come under the TRL level 7, 8, 9. It means testing and optimization. So prototype nothing, but if you take Vande Bharat train, before they are launching officially, they will do the trial run, or they will check the track, they will trial the speed of the train. So all these things has comes under the prototype. Then go for the field trials. Then optimization of the field trials. It means if there is any problem is there during the trial run of that particular thing, so they will optimize the product, and they will make the multiple product, and they will keep on study that one, and they will collect the feedback, and they will bring it to the market ready product. So any product, it is transferring from your idea to the market, that is classified into 9 levels. That is called TRL level 9 up to 9. So basic level, it is happen in the academic and research institution. So here, so I am going to discuss about new topic that is called for the past decade across the globe, people are looking for the hydrogen, green hydrogen, and gray hydrogen, blue hydrogen, like that. They are giving that different terminology they are working. As well as I have more than 14 years of experience in this hydrogen field. During my PhD, I worked on this hydrogen. And in the 2009, I worked on this CNG. And after 10 years, I saw the vehicle on the road, CNG vehicles. Now you saw the CNG four-wheeler, three-wheeler, like that. So I worked on the CNG vehicles on 2009, 10 itself. So along with the CNG, I also worked on this hydrogen. So now I'm the next couple of minutes, I'm going to discuss about hydrogen and its importance, hydrogen production technologies, and especially green hydrogen technologies and hydrogen scenario. What is the Indian scenario as well as the global scenario? And at the end, I will give what are the opportunities government is providing to come to attract that various researchers or faculty to do this hydrogen side research. So why the hydrogen generation technologies are important means, so to afford the future with a greener fuel from the endless sources, like hydrogen and water from the seawater. So people are talking about hydrogen electrolysis means only requires a pure water. It is not like that. There are people are working on the seawater electrolysis to generate the hydrogen. Why? Because we have a endless seawater we have, and to enable the large scale electrical energy storage as a chemical fuel. So the best example is if you want to travel 1,000 kilometers, 1,500 kilometers, you will choose battery car. You will choose the petrol or diesel car over to the battery car. Why? Because you cannot store 1,500 or 2,000 kilometers at a time in the particular storage system. So to enable the large scale electrical energy storage as a chemical fuel, so hydrogen is the another option. And followed by to minimize the emissions of the greenhouse gases. So whatever the gases you are using, whether you can use the petrol or diesel or fossil fuels or anything, so it will emit a finite amount of this carbon dioxide or other greenhouse gases. So where if you're using the hydrogen, it will generate steam as a byproduct. It is called water vapor. And what is the properties of this hydrogen means? It is a tasteless or colorless and lightweight, and it is a orderless and simplest element, and it is having the highest energy content by weight. How I will it is their energy content I will tell, and it is widely available as a secondary source. So it is widely available as a secondary source, and hydrogen can be used as a fuels for diverse applications. Like a petrol or diesel or electricity, hydrogen can be used in a different applications. So why people are looking for the hydrogen uh, across the globe over the other fuels means if you take that petrol, the petrol around that calorific value is around 44 to 46 megajoules per kg, whereas a diesel is around 42 to 46, whereas a CNG or LPG it is around 46 to 55 megajoules per kg, whereas a biogas it is around 35 to 40, whereas hydrogen have a calorific value of more than 122 to 142 megajoules per kg. If you take any of the best fuel existing best fuel, whereas the hydrogen have a more than three times of the calorific value. So that's why people are looking alternative fuels and they are encouraging the use of the hydrogen as the gas. This is the main reason to switch over all the companies or all the people are working towards the hydrogen production technologies. And so once you use the hydrogen and it is as a why hydrogen means it is a clean fuel with a greenhouse. There is no emission from the carbon dioxide, and it's having a faster refueling time than battery vehicle. Whereas if you are using the battery vehicle, you can use nearly just based on the vehicle or based on the kilowatt power. Maybe it is vary from 30 minutes to 4 hours, 5 hours like that. And better security, other commercial fuels, and economically competitive. Economically competitive once you can produce a enormous amount of the hydrogen. So the best example you can see in the 10 years back when I am doing PhD in 2010, and in that time 1 kilowatt solar is nearly 3 lakhs rupees. But after n number of people are working on this solar energy, and the 1 kilowatt cost of the solar energy is come decreases to nearly 60,000 or 70,000 or below that. So it means the adaptability, the mobile data. So the mobile data what we are using, maybe just you can come across. So 10 years back it is 200 rupees or 300 rupees. Now we are getting 2 rupees or less than 2 rupees, 3 rupees also we are getting. So this is the thing. It means adaptability is the one thing, and followed by the creation is the another thing to utilize the hydrogen. So what is the challenges in the hydrogen? So the main challenges of the hydrogen is like a petrol or diesel or coal or fossil fuels. Like if you go further in the forest and you cut a small tree and you can fire it, you can get the fire. So that is the primary source. Whereas the petrol, they will from the underground they are taking that uh, thing and they will boil it in the different process and they are separating that petrol, kerosene, and diesel and all these things and they are distributing. It means it is directly available. Whereas the hydrogen It is always associated with a some element. For example, water. Water is a H2O. So it means hydrogen is associated with the oxygen. Whereas fertilizers you are using every time where the crop season we are using various fertilizers. So the main element of the fertilizer ammonia. The formula of ammonia is NH3, where hydrogen is associated with the nitrogen, and other molecule is like methane is a natural gas that in many industries they are using. So it is hydrogen is associated with the carbon, and where is the methanol or ethanol. So there are a n number of hydrogen associated molecules are there. So you need to develop a technology to break that bond. To break that bond, you need a electrolysis to break the hydrogen and oxygen bond to generate the hydrogen. Or you need a technology like a previous talk that professor told that methane cracking. Methane cracking means you need to develop a technology to crack that bond, carbon hydrogen bond, and you have to collect that hydrogen and methanol, ethanol, or ammonia. So whatever it may be the molecule, you have to develop a different technology to break that bond. So to break this bond, once you break that bond, so there are a n number of things are there. Once you break that bond, once you generate it, that is called hydrogen production, transportation, storage. So all this infrastructure is very important. Not only production. So you have to be utilize the hydrogen, or where you are going to utilize, how you are going to store the utilize, how you are transport the hydrogen. So all these things will play into the market. So but so far there is a lack of market ready technologies are there for the hydrogen handling in the sense for hydrogen production as well as the hydrogen transportation or storage. So most of the hydrogen technologies are limited to the lab scale or research level. So that's what I'm saying. Very many people are in India working for the hydrogen generation technologies, but in IITs or CSR labs or many other academic institutions, they worked for the past 10 15 years. They are working for the more than 20 years. They are working, but it is in the lab scale. So it is not coming to the market ready product. So these are the types of hydrogen is there, and based on the process, based on the source, hydrogens are mainly classified into different types. Already previous professor told it is a green hydrogen, gray hydrogen, blue hydrogen, and brown and grid hydrogen. And this is the hydrogen technologies. So I want to brief about why people are looking only green hydrogen compared to black or brown or gray or blue or pink hydrogen means. So the black hydrogen or brown hydrogen, if you take the brown hydrogen, so by using the gasification, by using the process gasification from the coal, uh, they will generate the hydrogen. That hydrogen we can label it as a brown hydrogen. But if you generate the brown hydrogen, to generate a 1 ton of brown hydrogen, it is already limited, emitted 19 tons of carbon dioxide. So once it is already emitted 19 tons of carbon dioxide, there is no use to use this 1 ton of hydrogen. So same thing, already people are using steam methane reforming. It means that it will generate nearly 11 tons of carbon dioxide to generate a 1 ton of hydrogen. Whereas a blue hydrogen, already advanced gas reforming technologies are using, where it will generate a 0.2 ton of carbon dioxide to generate a 1 ton of hydrogen. So it means the thing is hydrogen is not the new hydrogen utilization is also not new. Only thing is uh, generate the hydrogen from the renewable sources is the new. Already many steel industries or cement industries, many industries are and pharma industries, everywhere they are using the hydrogen. But that hydrogen mainly from the coal or natural gas, that is brown hydrogen or gray hydrogen using. So government is insisting to them to replace this existing hydrogen with the green hydrogen. So the cost of this hydrogen, if you take, nearly 150 to 2 150 100 to 150 rupees will be there, whereas the green hydrogen is comes under around 600 rupees. It means three times is higher at present. So that government is always insisting to cast down the cost, reduce the cost from 600. That means it's a $5 or $6 to $1 or $1.5. Then only it is affordable. So that means we need to develop a technology by 2030 where we have to bring the cost down from $7 to $1.5. So like it is a mobile data or like it is a solar thing. So whatever it may be, you can think, but all we have to work on these technologies where to bring this cost from higher level to lower level. So this is the hydrogen economy. So hydrogen economy means people are working on the solar or wind energy, as well as now I'm saying that hydrogen generation. So once you generation, so some people are working on the hydrogen generation technologies. And whereas the second part is once you generate the hydrogen, we can use as a dispensing system like a CNG or petrol pump. You need to develop a some dispensing system. So in this all this sector, whatever it may be, except the catalyst part as a chemist, remaining all these things has to done by the each core engineering part. So 90% of the case has to be done by the requirement of the engineering things, whether you can take the mechanical or electrical engineer or theoretical things to develop these systems actually. So here one is dispensing system. In India, we have only two dispensing system. One is in IOCL Faridabad, another one is in the Leh. So that is just 3 6 months back only they opened. I showed the pictures at the end of my presentation. And second thing is the pipeline for transport. So second thing is for the pipeline for the transport. It means uh, like a petrol, other things. So you need to develop a pipeline for the gas. I think till to 2013, uh, so Nepal took that uh, gas from that India by vehicles. So after that, people are developing this pipeline. So they through pipeline they are getting for the energy requirements. So it will go for the refineries or fertilizers or steel industry. And second option is third one is you can store the hydrogen. So where people are storing the hydrogen from the four different storages are there. Whether you can go for the gaseous form, you can store into the liquid form, or you can store into the different cylinders like type 1, type 2, type 3, type 4 cylinders. So type 4 cylinders is the suitable where you can store up to 700 bar into the cylinders. So very 2 to 3 research groups are working in India for the hydrogen storage. And once you storage this one, you can transfer to the gas power plant or power grid applications. So like our telephone towers are there. Once there is no power and the telephone tower work on this diesel generators. So you can replace more than 1 lakh telephone towers are there in India. You can replace the diesel generators with this uh, hydrogen and fuel cell systems. It means you no need to go every time and to change that diesel or something like that. Once you can put these cylinders, automatically it will be power on. So these are the advanced technologies you need to be work. And the final thing is once we produce a large amount of hydrogen, where we can transport this hydrogen to the other countries. So like already Shri Pradhan PM is always insisting is like a India is going to be a green hub by 2047. Or recently the Chandrababu Naidu is also involving for 2 days back. By 2047 this is a vision on the clean hydrogen fuel. And already in Simhadri plant in Vizag and Greenco is in Kakinada is already they started large investment and hydrogen production technologies on this area. So whereas the NTPC. So like that, there are a lot of projects is going on in AP on this large scale productions are doing. Once they've done the large scale, so they will export this hydrogen to the other countries. And the third one, once you using the dispensing system, so like alternative of vehicles like a fuel cells, fuel cell bus or fuel cell two-wheeler, three-wheeler, four-wheeler also, it will come in future. Already in Europe or Germany or Japan and China or US, so there are more than 1,000 hydrogen stations are there, and there is a many transports are working on that. So I went to the Japan as well as the US. So I traveled this hydrogen buses, and they're using many places for this hydrogen buses in the couple of years back itself. And these are the hydrogen generation technologies. Already many industries are working on this steam hydrogen, steam reformation, electrolysis, and cracking technologies. And steam reformation, many industries are using. So like cement and steel industries or many other industries. Electrolysis are cracking technology. Now they are looking and they are diversifying the existing hydrogen technology to these two technologies. So from this one, electrocatalytic water splitting, already he told, the previous professor told us electrolysis and methane cracking. What is electrolysis means? So in electrolysis, there are three processes are there. One is electrocatalytic water splitting, photoelectrocatalytic water splitting, and chemical oxidation. So it means you are splitting the water by giving some potential to break that water. That is in in presence of some potential it is broken. That is called electrocatalytic water splitting. So in presence of light that is splitting, that is called photoelectrocatalytic water splitting. And by using some chemical reaction, we are splitting the water. That is called chemical oxidation. I am not going to brief about this thing. So I will show the outline of this thing, how it is, how it will work. So this is the PEM water electrolyzer. If you look at this one, if you are passing the hydrogen from the left right hand side, and that H2O is passing through the electrolyzer stack, and it will reaches to the membrane. It's called, mainly people will use as the proton exchange membrane. It means the H2O, H plus and OH minus will split. The H plus is transferring. You see, H plus is transferring, and the H plus is combined with another hydrogen and to form as a H2 gas. So it means it is transferring H plus. Generally, we can call H plus as a proton. So that's why if the process in the process membranes are transferring the proton, it means proton exchange membrane. So that's called PM electrolyzer, PM water splitting. It means the membrane is exchanging the proton. It's called proton exchange membrane. If the membrane is exchanging anion OH minus, anion exchange membrane, AEM electrolysis. So it means this is the process. And if you are taking this power from this uh, grid power or solar power. So that's what in the previous class professor told. If you take the power from the solar, that power we can call it as a green hydrogen. If you take the power from the grid power, then we can call it as a is called as a green hydrogen. So the advantage of the system you can see, it is unlike a battery. If for example battery it will touches to the water, or if something is the scratch is there, it will blast. But in that electrolysis stack, nothing will be happen. So and it is easy to maintain, and there is no impurities are there. It means you can generate a 99.59 purity hydrogen you can get. And once you develop the technologies, you can get the good returns like a return of investment, and it will also save the energy, and it is a safe to operation, and you can get a high yield or high pure hydrogen. There are in some pharma industries or some fuel cell technology, there you required 99 point more than 999 purity hydrogen is required. So for that application, PEM electrolyzer is using. So here, from this electrolyzer, there are a different components are there. So like you can use the DC source, and there you can use the catalyst layer. It is called membrane electrode assembly, and is followed by the diffusion layer will be there. It means you will pass the gas or diffuse the gas in this one. And once you pass diffuse the gas, and it will exchange the membrane, and it will generate the hydrogen already previously I showed. So this is the basic thing, so generally the engineering part in this one, except this catalyst layer, this is the developed by some material chemistry people, and remaining all these things, the channel design and s- type of the material, design of the material, and testing of the material, as well as this to increase the efficiency of that electrolyzer stack is completely design the thickness of the material or internal resistance of the material or quality of the material and the channel of the material, and all these things is im- play a vital role for the production of this hydrogen. And is my voice is clear now? Is going fine now?
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay, madam. Okay, okay. So this is the PEM electrolyzer, and this is the one hydrogen generation technology. So here in this electrolyzer technology, except this membrane, everything is available in India. Everything is available in India. Only thing is you have to be develop the stack, or you have to optimize the stack, and you have to test the stack, and you have to generate the hydrogen. So the membrane is across the globe. Only one supplier is there. That is the DuPont is the company. From 1963 onwards, he is the only supplier. And now many countries are realizing that now he is not supplying the membrane to all the countries. Now he is the DuPont is not supplying the membrane to uh, Asian countries. So now people are realizing and people are start working on this membrane technologies, and very few groups, maybe less than 10 research groups in India is working on the membrane development. And more than 300 400 groups are working on the catalyst development, like all many material chemistry people are working on this uh, things. And many people like a previous one professor is working, and yesterday is IIT professor is doing, they are doing for the simulations theoretical studies on that one. So these are the many people are working on this area to simulation. Simulation means everything they have to be correlate with the experimental data, and they were going to find out what is the best one or to choose the for the commercial scale. So it means in a single person it is not possible to bring the technology. You need a complete a supply chain is required to bring this technology into the market. So like that there are people are working on that, and this is the basic mechanism. So this is that next one is a PEM methanol electrolyzer. So methanol electrolyzer in the PEM water electrolyzer means we are passing the water and we are generating the hydrogen. Where in the methanol electrolyzer we are passing the methanol and we are passing the methanol and we are generating the hydrogen. And it is called bio-CNG or methane crack. Already the professor told for the methane cracking technology. So cracking in the nothing but at a high temperature, we are break the bond between the carbon and hydrogen. So we are pass. It is called. He's saying that solar cracking and all these things. So it means whatever the ultimate thing is, by using the grid power or solar power, we are cracking the hydrogen, and we are cracking the methane, and it will generate hydrogen as well as the carbon as a output. So it means, so there is a reusable chamber we are developing in India. So what during the process, what will happen? The hydrogen will be lightweight molecule, and it will emit from the cylinder or reactor, and the carbon particle is deposited on the catalyst surface or walls of the lab. So that means the for that purpose we developed a reactor where you can remove the complete chamber and you can reuse the catalyst in the reactor. It is called a fluidized bed reactor or fixed bed reactor that we developed in India, and currently we are using, and for the methane cracking system as well as the ammonia cracking system, where the only thing is by methane or ammonia, only thing is the temperature will vary as well as the catalyst will vary. So remaining things will be common. So here, and these are the core part and the design part, whereas the critical component is the catalyst. So across the globe, already I told that more than 300 or 350 research groups in various IITs or CSR labs and other institutes they are working for the development of the electrocatalyst. So why we need the catalyst means, I will tell one example. So we are using the in electrolysis is the iridium catalyst. Iridium catalyst, when I am doing PhD in 2013 or 2010, that time 1 gram cost is nearly maybe 3,000 or 2,000 rupees. So because of the Ukraine war and there is no proper supply of the iridium, now 1 gram is more than 17,000, 70,000 rupees, 70,000. If you get a high pure, there is second grade is there, you can get a 50,000 rupees. So if that, it means across the globe, the iridium is Ukraine only major supplier for the iridium. Now because of the war, because of the conflict, the prices are increasing. So it means people are working on the alternative of the platinum catalyst or alternative of the iridium catalyst. So if you take work on the any catalyst, it should have a minimum high surface area and good electrical conductivity. What we are using all are electrochemical systems. So it should have a good electrical conductivity and it have a long mechanical or chemical stability. It means like a batteries we are using after 1,000 cycles. If that all laptops or mobiles, what you are using after 3-4 years, we can see the battery down. It means the mainly lithium ion batteries mostly work on the 3,000 cycles. It is a 1,000 charge discharge systems. It means more than 1,000 cycles it is run. So automatically it efficiency of the battery will be decreases and availability and low cost. It means the availability of the is also important. Like people are realizing for that first 10-15 years only that only one company is there across the globe supply the membrane and only 1-2 countries are there supplying the catalyst for the platinum or iridium or ruthenium. So in India, we cannot get more than 300 grams of iridium catalyst as of now. Even 100 grams also is very difficult to get. No supplier are there. And 1 kg of platinum cost catalyst we cannot get. So it means that much difficulty is there to get the catalyst. Without catalyst, we cannot run any electrolyzer systems. So is it, that's why many industries or many startup companies or many institutions are working on this alternative of the catalyst. So that much important is there for the catalyst. Rest of the catalyst, everything is has to done by the engineering people. So it means the main objective of the research across the globe is identification of the suitable catalyst material for the PEM electrolyzer or AEM electrolyzer or fuel cell applications, and synthesis of a carbon or metal nanoparticle using a various methods like chemical vapor deposition or chemical methods, and application of the synthesized electrocatalyst material for the real-time fuel cell or electrolyzer applications. So this so far I covered that what is hydrogen and what type of hydrogen and what is the technologies are needed to develop the hydrogen and what is the challenges we have to be come across. So this is the one part of my presentation. And second part is what needs to be done to succeed in the green hydrogen. So far, these are the problems we have to come across. So to come across these problems, what is our contribution? What we have to do? It means, sorry. So it means 1 kg of hydrogen cost is nearly $5 to $6 has to bring into the 1 to 1.5 dollar per kg by 2030. And unlike the domestic demand of the green hydrogen. It means a small scale application like LPG cylinders we are using. So just imagine 30 years back, people are saying while introducing this LPG cylinders in a home, many people doubt that, questioned that, see that many uh, rural people or many housewives, they don't know how to operate the cylinder. So it may be blast like that. So, but people keep on adapting that new technologies and how to utilize the cylinders. And now, after 30 years or 40 years, just to imagine without a cylinder in a particular home. So that is means that needs you have to unlock the domestic demand for the same green hydrogen also. Some people are working on the green hydrogen burners and mixing of the green hydrogen into the CNG, mixing of the hydrogen into the LPG like that. It may be slowly, it is coming, and tap into the green hydrogen export market. It means once you develop these hydrogen technologies, you have to be export this hydrogen to the other countries. And PLI scheme, it means production linked incentives to capture the electrolyzer market. I think you come across in newspapers, they will say that Reliance started 30,000 crores and Adani started 20,000 crores on this electrolyzer market, renewable market means. So they will work on the large scale production. So they will create the facility and they will get that incentives from the government. So that's where large scale they will work. That's called PLI, production linked incentives in the electrolyzer market. So this is the uh, things we have to contribute by next 4 to 5 decades to bring the net zero into the to achieve the net zero targets. So this is the hydrogen scenario across the global level. So this is the hydrogen scenario across the globe, and these are the projects started where you can see that small things is early stage project and feasibility study and under construction project for this thing, and each one is minimum of 50,000 tons of hydrogen per year production to 7,000 tons. It means 7 lakh tons of hydrogen per year. This is the scenario across the globe. It means more than 1,572 projects is started, initiated already, and its market is nearly 680 billion market is there. And whereas India has showed the more than 110% increases in the investment for the past 3 4 years. And this is called, first one here I will show the blue color is a purple color. It is a 186 giga scale production. So how big that 186 giga scale means, for to generate the 1 gigawatt, 1 giga of hydrogen, it requires a closely 1 lakh employees to generate the 1 gigawatt factory. 1 giga factory is there for hydrogen generation. It requires a 1 lakh people. But in India, currently working more than less than maybe hardly 3,000 or 4,000 people in India. So it means that much gap is there. But India is looking for the 5 million metric tons of hydrogen by 2030. It means there is a lot of opportunities are there in this sector. Just you see how much gap we are there for the industry to the production level. So it means that much of huge demand is there in this hydrogen sector wherever you are working, whether you are working on the simulation, whether you are working on the design, whether you are working on the stack development, or whether you can working on the reports, and whether you are working on that testing, whether you are working whatever the area you can work. So there is a lot of opportunities are there in this hydrogen sector by till 2070. This is the market. So whatever that things is happened, this is the going to play a major role. And this is the hydrogen in a scenario where across the over 4.6 metric tons per annum clean hydrogen production capacity committed by 2030. So already North America only 2.3 metric tons per annum. Already it's started work, whereas China it is 1.3 metric ton. Europe it is a 0.368 metric ton per annum. Middle East is 0.27. Whereas India is already making the things is 0.046 metric ton per annum, and Africa is 0.046 metric ton per annum. So it means these are already companies, these are the already countries, they are start working on the production to achieve the 4.6 metric ton per annum hydrogen production capacity. It means the zero India where it is a 0.046 percentage. So that's why government is pushing to increase this number into the single digit. So this is the hydrogen production and global status. Whereas the only 4% of hydrogen is using in the electrolysis, and whereas the 29% is using from the steam reforming, whereas the hydrogen carbons oxidation we are using 49%, and coal gasification we are using for the 18% to production of the hydrogen. Whereas in the consumption also, so mainly more than 55% we are using the ammonia synthesis, where we are using the hydrogen, and 10% we are using the methanol synthesis, and we are using a 25% oil recovery, and 10% is using for the other applications. So hydrogen involvements, and these are the hydrogen involvements. This is the hydrogen is also. Next slide, I will show this hydrogen scenario. This is the hydrogen scenario across the globe we saw, and this is the hydrogen scenario in India. So the launch of National Hydrogen Green Mission by the Honorable Prime Minister on the evening of 75th Independence is aimed to make the country global hub for the production of the hydrogen. And the this is the initiative. This comes under the Atmanirbhar, self-reliant. And these are the schemes for the past 3 years. In 2020, they first started National Green Hydrogen Mission. And 2020 February, they started a green hydrogen policy. And 2023 January, they started, cabinet is approved for the strategic interventions of for green hydrogen transaction. And in 2020, there is a site program is there. And August 2023, they started a India definition for the green hydrogen by MNRE. That this is the you have to follow the process of the website is MNRE. They will keep updating the things. And in October 2023, R&D roadmap is initiated, and January there is a site completed, and February the scheme guidelines for the pilot projects using this one. And in 2024 March recently implementation of R&D scheme setting of a hydrogen hub. It means the center of excellence or hydrogen hub and a scheme guidelines for the skill development. There is a skill council green jobs is there that is already skill development. So the aim of the skill council is every year they want to train the 80,000 people on this sector, and they want to establish the skill centers, and they want to establish the center of excellence. So these are the roadmap to achieve by 2050. India is aiming to produce a 3 by 4% of its hydrogen from the renewable sources. So the what I want to convey here is, so across the many people across the globe, I have a discussion with them. Whenever I spoke to the Chinese people, so Chinese people always think what is the global demand and how much we are going to produce. They never think how much China is required and that much we cannot produce. It means what we think, so how much India is required, we can produce. So other countries they will think how much of particular country is required and how we are going to generate that one. But whereas the Chinese people, what is the global market? So how much is required for the across the globe and how we are going to contribute? Always people think like that. That is the very strange idea for them to succeed in this any area on this Chinese people. So this is the target. By 2020, already we are using a 6 million metric ton, and from the 6 million metric ton, we are not using even close to 0% of green hydrogen. Whereas at 2030, the we are using the hydrogen nearly 9 million metric tons for the refineries and chemical fertilizers. So by this is the clear instructions from the government. We have to switch over this existing hydrogen to the green hydrogen, and by 2050 you require a 25 to 30 million metric tons of hydrogen, whereas the 80% of you have to use the green hydrogen in this field. So this is the uh, for the first the couple of years we visited different places across the India and other countries, and this is the green hydrogen international conference on green hydrogen, the first and last one. And every year they are conducting, MNR is conducting, and try to attend this event. And last 2 months back we attended, and Prime Minister and other ministries has came, and they give a lot of inputs on this one. And this is the hydrogen fuel cell bus. It is a Jitendra Singh Union Ministry's unveiled that bus, where during the 2014 or 15 I worked in this institute, and SICRI and other private organizations, they combinedly developed this fuel cell bus. The time I worked my PhD there. And this is the Nitin Gadkari. 1 year back, he came to the hydrogen car to the parliament, and this is that Tata Merai car. And we went to Goa. There already Reliance and Ashok Leyland, and they projected that hydrogen buses. Yesterday, that professor told that hydrogen engines. It means this is the bus. This is called hydrogen fuel cell engine buses are there, and hydrogen combustion engine buses are there. These are the hydrogen. combustion gases. And the upper one is IOCL. And this is the 2 months back. We are attended. We also went there, and this is the IOCL event where they launched the 10 buses, and IOCL as well as the Leh. Already they started 10 buses. So in the Leh, it is on the trial basis. The first bus, it is with the Tata, they combined and they developed that fuel cell bus. Now it is under trials. And after trials, they will make the feedback and they will modify the bus accordingly, and they will modify according to Indian conditions, and they will working on that. And this is the first hydrogen train. Already major research is going on in Chennai Rail Factory, and already I think Vaishnav is also mentioned hydrogen fuel cell trains. So it is also working. Major R&D is going on in Chennai. And this is the myself. I went to the New Delhi 1 month back. It is a 1 megawatt electrolyzer. The different refinery industries are showed. It is my colleague and myself who went. It is in that again. It is in Mumbai, I think, or Mumbai, not Mumbai, in Delhi only. And Tata Mirai hydrogen car. And this is the stack. There are some other companies also displayed. And this is the states implemented policies on the hydrogen. Already out of 22 states, already they implemented. And Andhra Pradesh green hydrogen policy of ammonia policy, it is also implemented. At that time, the Snara Chandrababu Naidu sir and they came to the last month. I think it is in September 22nd or something in Gujarat. It is the Reinvest Summit. Already they opened this one, and CM sir has also given that detailed presentation. Just you can go open on the Reinvest Summit in Gujarat. So there they given in this Andhra Pradesh policy. So we also attended there and that event on that one. And what is the hydrogen use case means? This is the state level and India level scenario. And what is the hydrogen use case? We can use the hydrogen and everywhere. We can use the hydrogen fuel cells, or hydrogen in pharmaceutical, hydrogen in metal or steel production, or transportation, power plant, power generation. So one thing is very interesting is the bottom left one is called net zero houses. Net zero houses means the house is completely independent on the grid power. That house we can call it as a net zero houses. Already in the main places on the main in Oman, Saudi or Dubai, they have the net zero houses. It means the daytime they took the power from the solar, nighttime they took the power from the hydrogen. That house we can call it as a net zero houses, and the blue color you can see that is called hydrogen electrolyzer system, and they will generate this hydrogen and that is used by the fuel cell and they will get the power. The left black one, it is that hydrogen 1 kilowatt system. Recently we got it from the US for the one of our client. So this is the hydrogen 1 kilowatt system, and this is the components already explained. This one, and green hydrogen till date, what is the project? It is there, and NHPC hydrogen based mobility station project in Kargil, and NHPC pilot project of the green hydrogen based mobility. It means these are the projects undergoing at present in India till date, and Indian Railways pilot project for the convention old steel, and NTPC integrated hydrogen refilling station in the Greater Noida, and NTPC is also working in the Simhadri plant in Visakhapatnam, and Oil India Limited is working on the green hydrogen generation pilot project in Assam, and Oil India Limited green hydrogen pilot project in the Himachal Pradesh, and Indian Oil R&D Center Faridab is working on this fuel cell bus already I showed in the picture. And NTPC Green Hydrogen Project integrated refueling station buses in the Leh Ladakh already I discussed. And India's first hydrogen fuel cell ferry, it is also working in this along with this KPIT. And Kerala is also working towards like green hydrogen shipyard and so many projects. And it is in the mobility sector and container vessel and storage type 4 cylinders. Already I told very few groups are working on this type 4 cylinders of this hydrogen. And these are the microgrid application, export oriented project and electrolyzer manufacturing, domestic sector and aviation sector and steel industry. There are many companies already they are working on this green hydrogen. They initiated the project, and by next 4 decades, this will play a major role. So, and with this one, I am going to bring one notice that there is an institute called Skill Development, Skill Council Green Jobs. in India. So they are giving the training to the manpower, those who are coming to this sector, and they are establishing nearly 100 skill centers in India. So in Telangana, we are also having MOE with this Skill Council Green Jobs, and we are also establishing the skill center. So in future, so maybe after 3 4 months or by next financial year, they will start the skill training uh, for the 80,000 people. That is their target. Those who are coming to the this area. So this is the different scenario things as the time is approaching. So I want to speed up the things. And with this one, with this strong knowledge of more than 14 years of experience, and we started this Nano Soul Energy Private Limited company after my PhD in 2020 December. And these are our expert team. Dr. K. Nagamahesh and myself, Dr. M. Shankar Rao, and Dr. J. Sarda Prasad is the process engineer consultant. And collectively, is more than 40 years of experience we have, all these three people. More than 50 years of experience is there, combining of these three people on this hydrogen sector. I think it's the right case. Sarda Prasad is the first person in India is completely developed the prototype of methane cracking and ammonia cracking systems. And what we do is we'll develop the process technology for the hydrogen technology productions, and take the process development of the electrodes like a consultancy, and we'll design with our technical team, and we'll train the manpower in the area of hydrogen production and application and storage systems. So exclusively we are working on the PEM and alkaline electrolysis like fuel cells and CO2 conversion technology and methane and ammonia cracking technologies. And this is our capabilities of our team will doing that. And these are the hydrogen generation systems like a test system. It won't generate the hydrogen. You can test your cells in these hydrogen systems, and we exported this system, and we many IITs and IOCL and CSR labs and many deemed universities, we created the Center of Excellence facility with these systems. And this is the system of fuel cell test system where you can check your fuel cell things in the system. Stack. These are the stacks. We are exported the stack to the Europe, Australia, and Canada and US also. These are the stacks we are developing where you can test your material like catalyst material uh, by keeping the stack, and for that purpose they will use in the single cell stack, 5 cell stack, 10 cell stack like that. And this is the membrane making system where you can make the membrane electrode assembly. It is very hard of the fuel cells and electrolyzer. So with this system they will make. So in our office we can develop these systems and we will deliver. And this is the demo of the 3 liter per hour hydrogen generation. He's that uh, Sunil Sharma. He's the IAS officer, Chief Secretary for Government of India. He's inaugurated 3 years back this our hydrogen electrolyzer system in Hyderabad. He's the Professor Danaya. He's the TF Gridco's chairman, and he's the solar director from the Telangana government. He is the presence of this one. And the systems across the India, I presented many places. Uh, and we are also part of this Telangana Hydrogen Innovation Cluster. And already told we are a part of this Government of India Skill Council Green Job, where we will give the training for the manpower. I am the part of that one. And we got award in the Net Zero in 2023 from that Government of India, and is delivered. And we are also noted in that Hindu business column on this hydrogen production technology companies. And so I gave also many presentations like this, and across the India as well as this other places. And this and also we give the training for this various IIT students and some other people. And these are our clients. Clients means we are closely working with many projects with this various companies. More than 30 companies are there still at many project under process. And with this one, I thank you to the Lacrate Quality Management and the HOD sir and other organizers. Thank you for your invitation and providing the opportunity for me to showcase my research findings in this platform. Thank you, sir. Thank you very much. I think it is my third presentation uh, in AP. So only in IAP, Indian Institute of Petroleum Energy, they are also working on this hydrogen and some other places. Thank you, sir. Thank you for this one. I am very happy to present in this place. Thank you.
Thank you, sir. It gives me immense pleasure to thank Shankar Rao sir for delivering such an insightful, engaging lecture on prospects of hydrogen as a clean fuel. Sir, your session has not only enlightened us about the transformative potential of hydrogen energy, but also inspired us to think critically about its role in shaping sustainable future. We are grateful for your valuable time, effort, and the knowledge you have shared with us today. Thank you once again, sir, for being with us, making this session so impactful to all the participants. Now,
Thank you, sir. Thank you.
now any queries from the participants, please unmute and you can raise your doubt. Dear participants.
Dhanraj sir,
Hello, sir.
before asking question and answers, please take a snapshot with all participants switching on their videos.
So Vijay Kumar, sir. Thank you, sir. Thank you for your invitation. Sorry.
Sir, you have given wonderful talk, sir.
Thank you, sir.
We'll
Thank
be
you,
in
sir.
touch with you.
Sure, 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 sir.
Thank you so much.
Dear participant, please switch on video so that we are having a snapshot for AICTE upload. Please switch on video for 30 seconds.
Shankar sir, yourself also, sir, please.
Yes, sir. I already switched on this, sir. The first one.
Sir, okay.
Sir, please stop sharing your screen, sir.
Okay, sir. Okay, sir.
Mallikarjun sir.
Yes, sir.
Mallikarjun sir.
Yes, sir.
So, majority of the participants have switched on their videos. Is it
Yes,
appearing?
I already took the screenshot, sir.
Okay, thank you. Now, Dhanraj sir, you can go for question and answer sessions. Okay.
Yes, sir. Yes, sir. Any questions from the participants?
Sir, Shankara sir.
Yeah, please, sir.
Sir, can you give any training to the students, sir?
Sir, already there is, we don't give training directly, sir. Through Skill Council Green Jobs will provide, sir.
How to approach for training, sir, for the students?
You can type in the Skill Council Green Jobs, sir. They will update each time, sir. They will scrolling on go every 1 month or 15 days. So you can register on that one, sir. Not only in that Nanosol, many other places also they will provide, sir. So they through government we are approaching that one, sir. And the thing is there, the government will pay the amount on behalf of student to that one, sir.
Okay, sir. Okay. Thanks. Thanks.
Yes, sir. Yes, sir. Thank you.
Shankar sir.
Yes, sir.
One batch of my BTech students are doing the project work in this area, sir, hydrogen energy related area. So
Sure,
if
sure,
any if any suggestions needed from your side, I will contact you, sir.
sure, sir. Sure, sir. No problem, sir.
And I'll
Always
send my
welcome, sir.
students also to Hyderabad to clarify their doubts.
Okay, sir. No problem. Always, sir. Always.
Thank you, sir.
Sir, good evening, sir. I have one question, sir.
Yeah, please, sir.
Sir, so it's a basic question. So,
Yes, sir.
already we are going to buy the water. So we are going
Okay.
to take hydrogen from that means the water scarcity will get. So how to
No,
manage?
no, sir. It is not then the water scarcity. I am not saying at present people are using the deionized water only. But many people are working on the hydrogen generation from the seawater, seawater electrolysis. So where
Okay.
you cannot find any this one, sir, scarcity of the water. So that is
Okay.
also in the development stages, sir.
Thank you, sir. Thank you.
Thank you, sir.
Hello, sir.
Yes, sir.
Sir, I'm a mechanical engineer. I want
Okay,
to
sir.
start. I want to start research in green hydrogen. So where should I
Okay.
start? Where should I start? And what are the facilities required to start research in green hydrogen?
So the thing is in that main part is what is the component of the fuel cells or electrolyzer, and except catalyst part, all other parts is comes under the mechanical only, sir. So right from the design, testing, and optimization, these things, sir. So like at present, people are using the different material like SS or titanium or different grades of the titanium and different flow field studies, and each flow field have its own advantage and its own efficiency. So that type of things as many people are start working on that, sir. So that is the one of the major area, and you can choose any of the designs, sir. That is also the one thing. So everything is the native stage, sir. First you can observe the literature, sir, or go through the literature survey, and what is your keen interest on that particular domain, where you can go for the next step, sir. That may be one of my idea. That's it.
Okay, sir. And what are the facilities required to start research, experimental
So
research?
this experimental research means already I showed in that my PPT, you need a one electrolyzer test system and a small cell and one hard press. So if it with these three, student will know what is electrolyzer, how the electrolyzer is working, what is the role of each component. So nearly more than 200 components are there. So he knows what is the role of each component and how it is working, what is its function, what is its modification. All these things the student will know from this one, sir. So already in that so many VAT and Shivnadar University as well as this SRM, they started this facility, and in IITs also they started in this hydrogen technology as the upcoming courses along with the CSE and mechanical engineering. They introduced there's a hydrogen like it's not in the hydrogen, it is a renewable technologies. They started some MTech programs and they are introducing this things, sir, slowly one by one. If you go to the IIT Roorkee or IIT Delhi or IIT Madras or IIT Hyderabad curriculum, so it is there on this hydrogen. So there, these are the basic systems as required. What I showed in that PPT.
Okay, okay, sir.
Good
Thank you,
evening,
sir.
sir. Sir, good evening.
Yes, sir.
Sankarov, sir. Sir, I
Yeah,
am
please, sir.
basically electrical engineering faculty, sir. So I am started my research in green energy production and
From where,
electricity.
sir? From
I am working on Godavari Institute of Engineering and Technology, Rajahmundry, sir.
okay, sir. Great college. Okay, sir.
So, yes, sir, sir. So which component or where we can start my research on green hydrogen with
No, sir.
respect to yes.
Yes, sir. This electrical components is majorly people are working on that present manual systems, sir. So they want to upgrade into the PLC or automation systems, sir. And
Sir,
they are using that different types
possibility
of the
sir,
sir.
possibility to integrate renewable energies into green hydrogen production, sir.
Yes, sir. Yes, sir. That's what I'm saying, sir. In that integration part only. So there is no proper software as there. People are not developing that PLC.
Sir.
PLC or this type of parts is major importance are there, sir. At present, only people are working on the manual systems. So all these things need to be updated or need to be developed some software or some PLC systems or touch screen systems. And this is the logic and temperature controllers and level switches. If you are using for the people are using the gas liquid separator, they need a level switch. or some sensors need to be developed at a particular point, automatically it has to switch off, or for particular level it has to be automatically switch on. So these type of things many people are doing, but they don't know the conjunction. So it means you cannot put transmitters, proper transmitters for this gas liquid separators. So any gas liquid separator, solid gas separator. So these are the core areas, sir. I know many people are not working on that. It may be one of the area I come across.
Sir, are you provide any support, sir, for doing projects, many projects regarding to integrate renewable energies to
Support means, and what type of support, sir?
like projects, sir, project support?
See, actually, the thing is here, we are basically a manufacturer.
Okay, sir.
So already that few of the components already we are doing that one, and other support of suggestions are something that I am ready to do that, sir. No problem.
My requirement is for designing a mini project with renewable energy sources. From that to produce the green hydrogen, thereby storing. If it is required to utilize in the production of electricity and other application.
Sure, sir. We will discuss it, sir. Please write an email, sir. Then we will discuss sometimes. No problem.
Thank you very much, sir. Thank you.
Thank you, sir. Thank
Sir,
you. Sir.
good evening. Sir, good evening, sir.
Yes, sir.
Sir, good evening, sir. Sir, I want to know the simplest method and also less cost method to produce hydrogen, sir. Green hydrogen.
Sir, I am talking more on the production of the hydrogen and possibility of hydrogen. Once the adaptability is there, then automatically cost will change, sir. At present, steam methane reforming and these things are there. Already coal-based hydrogen, where you can, it is cheaply by 1,000 rupees, less than 100 rupees also it is there per kg. So to
Okay,
replace that hydrogen only, people are working on this electrolysis. At present, that 1 kg of hydrogen is cost around 600 to 700 rupees. So it means
yes,
we have
sir.
to be optimize the parameters, then we can minimize the cost by coming years.
Okay, sir.
Yes, sir.
Any more queries from the participants? If no queries, we will end the session. And we will already share the today's feedback link in our WhatsApp group. Please fill the feedback link. Shankarrao sir.
Thank you, sir. Yes, sir.
Thank you so much, sir.